So in previous video, we have seen that the bus system consisting of 4 registers and how the transfer is being done with the help of the multiplexer. So 4 registers are there, multiplexers are there. Low order bits will be given to multiplexer 0 and high order bits given to multiplexer 1, and the output will be placed on the bus. That is, the multiplexer output will be placed on the bus and the bus line will be connected to all the registers. Okay, so now what is the task is, this data need to be loaded to some of the destination register. Okay, so in order to load the data to the destination register, we make use of the destination decoder. Destination decoder we are making use of in order to load the data to the destination register. So for that, again here we are having some select signals and then an enable will be there. So this enable enables the decoder, that is a 0 input will be taken, 0 input, it initiates the decoder in order to load, which indirectly load is being enabled, and this helps in loading the data that is currently available in the bus to the target register. So how the target register is being identified? With the help of the select signals that is given to the destination decoder. So here also we will be numbering the registers as 0, 1, 2, 3. So 4 registers are there. So we will be making use of 2 bits to represent these 4 registers. If it is A register means 0, 0, B register means 0, 1, C register 1, 0, D register will be like 1, 1. Okay, now if the micro operation is given like content of A will be transferred to content of C. Okay, content of A, if it is um, loaded to content of register C, so this can be considered as a micro operation. So with respect to the given diagram, how the multiplexer will be choosing the source. The source chosen need to be a register A. So in order to choose the register A, the select signals on the multiplexer, it will be giving the input as 0, 0. Okay, so this 0, 0, it helps in enabling the register A. Okay, so the multiplex sum output register A bits will be enabled and it will be stored in the multiplexer, and that information will be loaded to the bus. So the low order bit of register A will be loaded to one bus and the high order bit of register A will be loaded to another, the same bus in the same bus. Okay, based on the number of bits, this lines will be based on the number of bits. Okay, so these 2 lines, it will be forming the bus in this diagram, and the number of lines inside this bus will be based on the number of bits that is used inside the register. Okay, so next A will be chosen by enabling the signal that is a 0, 0 in order to select the source, and based on the input that is given 0, 0 in the multiplexer, it helps in loading the data from register A to the bus. And next എന്താണ് destination register എന്ന് പറയുന്നത്, it is C. So in order to enable the or identify the destination register, the select signal over here, it gives 1 0 1 0 signal. So 1 0 signal will be given as input to the destination decoder. So before that it will be enabling the decoder using this 0 input. So if the 0 is given, then the decoder will be enabled, which helps in performing the load operation for that particular bus. So the load will be given, the load is initiated for the particular register. So in this destination decoder, inputs given will be like two inputs to identify the target register, and the other one is like enabling the decoder, which initiates the load operation to individual registers. So if 10 if it is given means it will be initiating what, the load operation to the register C. Okay, and then the data that is currently inside the bus. So this data, it is currently inside this bus, isn't it? So the data will be placed on the register C. So load will be connected to all the registers. Bus also will be connected to bus, and its lines will be connected to all the registers. Okay, just go through the program, draw by yourself and see whether you are able to understand. Else we can discuss the same in next class also. Okay, so by performing these operations you will be able to load the data from A to C. And how, first from A it will be placed on the bus, and then from the bus it is placed on register C. Next is like the memory transfer. So the previous case what we have learned is between the registers transfer of data we have seen with the help of multiplexers, bus and decoder. Now next concept is like the memory transfer. It makes use of the memory registers. So memory transfer means it initiates the read as well as the write operation. Read operation is like it transfers the information from the memory register to the outside environment. Write operation is like transfer of new information into the memory register. This we have learned in the previous module itself, in the first module itself. Read operation is like you will be having the data inside the memory. That data will be read. So memory means you will be having some addresses. So from the specified address, the data will be taken and will be placed on the data bus, and from the bus it will be placed on the memory data register or memory buffer register. Okay, one memory is there which is divided into some number of cells. You will be having memory address register and memory data register. Okay, now memory address register, it will be giving the address on the address lines. So there is a bus between this memory and the memory address register. So MAR will be placing the address on the address lines of the bus. MDR will be taking the data from the data lines of the bus. So based on the address that is being given in the memory, the data will be fetched and will be placed on the data lines of the bus, and which is retrieved by the MDR or MBR. So this operation, what it is called as the read operation. And in case of write operation, what happens? MAR will be having the address, MDR will be having the data, initiates the write operation. So both the informations will be placed on the address lines and data lines. And based on the address that is available in the address line, it selects a cell where the data need to be written, and the target data that is available in the data line will be placed on that particular cell. So that is the write operation. Then the memory register will be used. That is, memory register will be represented making use of the letter M. Okay, memory in പറയുമ്പോൾ it will be making use of some memory register which is represented by M. And memory register is specified by an address necessary when writing memory transfer statements. So this memory, if some operation is related to the memory, means it makes use of the address, and in such cases the memory register is required so that you will be getting the address where the read as well as the write operation can be performed. Okay. Now this is what we have learned. This things it is known to you. You will be having a memory unit. MAR is there. MBR is there. So in previous module we learned it as MDR, memory data register. It is same as MBR, memory buffer register. Okay. Why it is different means both the contents it is differed from different texts. It is taken from different textbooks. Now, first module you have referred the Karl Hammerscher book, and the second module was taken from the Morris Manor. In that MDR, instead of MDR they have they are making use of the term MBR, memory buffer register. Both are the same. Okay, so here read and write signal is being given as a control function. So if R is enabled, read is enabled, what happens to the memory buffer register? From the memory register, data will be loaded to the memory buffer register. If write is enabled, then from the memory register, from the memory buffer register, data will be stored to the target memory register. So it makes use of address and data registers. Memory word is specified by the symbol M followed by a register enclosed in square bracket. Okay, so it makes use of many address and data registers. Address registers means it will be dedicated to store the address, and how that content memory word, how that word will be taken is like, or the address will be identified will be like M of for M followed by the square bracket. Okay, M followed by the square bracket, and inside that square bracket you will be having the register. So that is the information which will be loaded to the B0 register. So memory read operation can be written like this. Okay, which means that A3 is having an address, and that address will be having some data which will be loaded to B0. So in order to retrieve that address, we make use of this M square bracket. Similar is the case with the write operation also. W represents the write signal, which if it is enabled means M of A1, which means A1 is some address it is having. M of A1 means the memory word that is stored in that address will memory word representing that address. Okay, so B2 is a register, and the content of B2 it will be loaded to that particular location. That is right. And here also it makes use of multiplexers and decoders in order to select the source and destination. Multiplexers and decoders will be used. Similar, it's equivalent to the previous thing. Only thing is we are making use of an extra module, that is the memory unit, and read and write signals will be enabled. Similar to the other one, we are making use of some registers. In previous case, we have used 4 registers only, and that 4 registers will be from that 4 registers it will be acting as the source as well as the destination. And in this case, we are making use of 2 registers. 2 types of registers. One is address register, and the other one is the buffer register. A indicates the address register, and B indicates the buffer register.